Today's video will demonstrate how to implement the graph using the adjacency matrices, otherwise known as the grid. Hello, I'm James Helfrich. The grid implementation of the graph is very efficient at adding, removing, and checking the existence of a given edge. This video will demonstrate how to implement the graph using the grid, otherwise known as the adjacency matrix. There are four ways to implement the graph. One is a connection of interconnected nodes where every node corresponds to a vertex in the graph and a pointer corresponds to the edge. The second is a set of edges where the source sink edge constitutes one element in the set. The third is an array of sets where you have an array of source vertices and every element in the array has a set of destination vertices. This video will demonstrate the grid implementation, where we have a two-dimensional array of Booleans. The horizontal axis is the source, the vertical axis is the sink. If a true exists in that source sink location, then an edge exists. The UML class diagram for the graph looks as follows. First of all, we have a graph, and we have the constructor, the assignment operator, the empty, size, and clear. We also have an add source and sink, remove source and sink, and we want to know if there is an edge between a source and a sink. We can also get the set of all possible edges from a given source, and we can find a path from a source to the sink. These last five methods require a vertex. Our member variable will be a grid, and this will be a two-dimensional array of Booleans. Notice this is going to be an n squared in size, where n is the number of vertices. To demonstrate how this works, we're going to start with a graph of 5 vertices. We're going to have 0, 1, 2, 3, and 4 as the name of our vertices, and our grid will be a 5 by 5 array of Booleans. Initially, every element we set to false. Now I want to add an edge between 0 and 1. So between source is 0 and 1 is the sink. So I'm going to look at the source of 0 and 1 is sink, and I'm going to mark that as true. Now I want to add an edge between 3 and 0. So source is 3, sink is 0. So source 3's thing 0, I'll put a true there. Now I want to add an edge between 3 and 2. So between 3 and 2 and 3 and 2, I get a slot there. And I want to add an edge between 3 and 4. 3 and 4 and 3 and 4. Notice how we can look at the 3 column of our grid to see all the possible edges. There's an edge to 0, to 2, and to 4. I want to add an edge between 2 and 0, 2 and 0, and 2 and 0. Now if I want to remove an edge between 3 and 4, then I take the 3 and 4 and I assign that to false, which means one slot disappears. And finally, I want to add an edge between 0 and 4, 0 and 4. And now my grid is complete. Let's take a look at the implementation of the most important methods for the graph. The first method is edge. If I want to know if an edge between a source and a sink exists, then I just look at the grid, and if that's a true, then there's an edge. If it's a false, it's not. This is O sub 1 because I do 2 array of lookups, and array lookups are independent of the size of the array. If I want to find a set of all possible edges, then I have to iterate through every sink for a given source. So this can be O sub n. And if that element is true, then I got to add it into my set, which is log n. Therefore, the total cost is n log n. If I want to add an edge between a source and a sink, then I set that element to true. Once again, this is O sub 1 because an array lookup is O sub 1. And of course, I want to remove an edge between a source and a sink. I got to set that slot to false. And this also is O sub 1. Okay, see if you can draw a graph representing the following grid. Pause the video, draw out the graph, and then resume the video to see how you did. Okay, so we'll start with 4 vertices, alpha, beta, gamma, and delta. So we're going to start with alpha to alpha, which is going to point to itself, alpha to delta, beta to alpha, beta to alpha, gamma to alpha, gamma to alpha, gamma to beta, and gamma to delta. And now my graph is complete. Okay, see if you can draw the grid corresponding to the following graph. Once again, pause the video and resume it once you're finished. Okay, here's my solution. Notice how there are 8 vertices, 0 through 7, so I have an 8 by 8 array. I'm going to start with slot 0, and 0 to 1, 0 to 1, 0 to 2, 0 to 2, and 0 to 4, 0 to 4. Now I'm finished with that source. Now I'll do source 1. So I'll do source 1, and 1 goes 1 to 3, 1 to 3. Now I'll go vertex 2, and 2 goes to 4, and that's it. Next, I'll do vertex 3, and 3 only goes to 6, so 3 goes to 6. Then I'll do vertex 4, and 4 goes to 0, 4 goes to 5, 4 goes to 7. Next, I'll look at vertex 5, and 5 goes to 4, 5 goes to 6, and 5 goes to 7. Now we'll look at vertex 6, and 6 only goes to 4. Now look at 7, and 7 only goes to 2. And now my grid is complete. You can learn more about the grid implementation of the graph in the grid section of the graph chapter of the C++ data structures textbook.